was just the default. It was the same thing for the room review. I just used like the same video and audio from that and loaded it in. That's
fine. I thought what I'd do is wind up the course with some things that we really can't cover, but they're the leap-off points. Is where you would go next if you were kind of interested in following this up on your own. First thing is, of course, if I were you guys and you wanted to have real stuff in your scene, the characters and everything, you'd want to learn Blender. So you should, you can learn Blender. It's free. The program's free, and the education is lots of different classes in it online. And Blender is it's a way to design 3D characters and make them move and do everything. And then what you simply do is save them to a file, a JavaScript file, and then this program will bring them in, and you can run them in your program. What I did this week was, last time I showed you like a flamingo and a horse and a character that were just brought in from somebody else's. They just made those things, and I just brought them in and showed you how they move. They sort of move. This week what I did is I incorporated them into the scene by, instead of just having them flap, I had them like fly around or run around as a horse runs around. In other words, I took their motion and made it 3D. Remember, when you have a character, there's one point, which is the central point, is the top of the hierarchy, and that's the point that you actually move around in the scene. All the motions of all the other things are based on that point. So that point is that's its location. You say, where's the character? It's at that point. That's where it is. That's 0, 0, 0 is that point. And when you move it around, that's where the character starts moving around. So if the character is just walking, for example, just walking like this, if you take that point and you move it forward a little bit, then it'll appear like he's walking as he moves along. So there's two kinds of motion. And one of them is the dynamics of the limbs and everything, and the other one is the actual positioning of the character, which this week was what I did. What I did was the flamingo and the horse was galloping, or I guess he was galloping, and the flamingo was flying. But what I did was, they were just standing in one spot. What I did was, looking from the top down, I just simply made them go in a circle around like so. So in other words, that he's flapping and he's going around that circle. Okay? But I did a couple of other things. I'm going to kind of show you how the code for that worked, because it's to start off with, in the beginning, he was just here, doing his, we were looking at him like that, and he was just sitting there flapping his wings, okay? And so what I did is I had to get him out to the outer edge out here, and had to stop moving him around. So the first step is you have to move him from here out to the outer edge, okay? The question is, how do you do that? You could simply change his X and Y. You can say, position is X here, and position is Y here, and put him out someplace. Yes, that would do it. That would put him over here. If you want to put him over here, you can do that. But the question is then, how do you get him then to fly in a circle? So instead of doing that, you probably recall in the beginning of the class, for the 3D stuff, when we first started talking about it, we were talking about the camera, and we built an object, and then what we do is the camera would move like this around the object to see, look at it in different positions. So if he hasn't got an object here, this is us over here, what we would do is we would just simply move around the object to see the object from a different side. You remember that? That was just in the beginning. We just did a little bit of that. And so what I said was, what happens is we were always at the same distance from the object. We never changed distances, but we just simply went around the object like that because we had the ability to rotate and stay in the same position. And we did that with a function that I had that said you decide what the distances you want, and then you decide what angle it is, and it will put you in that XY position. So in other words, if you know the distance you are from the center, and you know what angle you are from the original position, which is right here, whatever angle you are, if you know those two things, how far it is and what that angle is, it can tell you what your XY position is here. So all I simply did was say that when you hit the left key, what it would do is it would increase the angle, and then it would calculate from that distance where you would be, what your XY would be. So that's why when you hit the left arrow and the right arrow, it calculates your new position. But it's always based on us looking at the center, we're always looking like this. That was the very first programs, because we weren't the camera. We were the camera, but we were stuck in the camera, and whatever the camera did, we had to do too. Now it's different. Now we can actually turn the camera and walk somewhere else. We can look around, do different things. That's because I took over the camera position, and I decided instead of looking at the middle, we could look anywhere we want, and we could go anywhere we want. So instead of being stuck out here, we could go in any direction, and wherever we went, our XY was still calculated. It knew where we were at all times. But originally, we just had that thing with the circle that went around like so, and we were stuck. Well, there was a special function we used, or I used in the beginning, which said what angle you at and how far are you from the center, and it would calculate your XY. That was the thing that we had built in. So the question was, when I have this flamingo now, it's sort of in the same position. It's sort of like going in a circle, so therefore I wanted it to be out in the circle out here, and I wanted it to fly around. So in order to do that, what I needed to do was a simple thing. I had to say, okay, I want to draw the flamingo at every XY position that he would be at, wherever it is. So I made the flamingo. You know how you add this kind of thing right here, where you say angle plus equals 0.01. You've seen stuff like that before, where I say in the rendering function, I add 0.01 to whatever the angle is. So every time it hits this, it adds 0.01 to the angle. The angle keeps changing. So in other words, what you have here, if you have a line like that, if this is angle, the angle of this thing here, this angle here, keeps changing by 0.01. So it keeps changing, and it's sort of like the character's moving in a circle like that, because its angle keeps changing. And then if you know this distance right here, if you know the angle and the distance, you can do a calculation. It will tell you when you change the angle, you can take that angle and the radius of the distance from the center and plug those into a formula, and that formula will tell you what your X is, and another one will tell you what your Y is. So you can get both of them back. And it looks like this. The formula looks like this. Let's say we're going to say, we'll call it the new X position. Where am I now? Okay. New X position equals, it's called GOX, parentheses, radius, dot angle, like that. Radius and angle. So what you do is, you say, if I go to this function, and I send it out, if the thing is out at this radius right here, if I send that radius there, and the angle, how much of an angle have I changed, because I'm adding 0.01 to that angle all the time. What it'll do is it'll take that angle and that radius and it'll calculate where you are now, what X you're at. It simply does it for you. It's built into our graphics XX. And if you want to know what the Z position is, now you normally, on a regular screen, you find out what the Y position is. But because of the fact that we're out in the Z direction, and the thing is flying around in the X direction this way, and in the Z direction that way, because it's coming at us, like that, then what we do is we say the new Z, just give it a name. I'm just giving it this name. New Z is equal to, this one here says go Y, radius, dot angle. I'm going to set these up so you can see them. I'll put them in radius, dot angle. And what that does is it calculates the new Y position. So in other words, this thing here will tell you, if you know that distance right there, the circular distance, and you know that the angle is whatever it was plus something, knows that's its angle, whatever angle it's at, this angle right here, whatever this angle is, you plug those two things in, that angle and that radius, it'll tell you where you are in the X and where you are in the Z. So in other words, what will happen is as you fly around, your X and your Z position will always be known. So you can draw the character at its X and Z position by simply saying, position the character at X and position the character at Z and draw it, and it'll be there. You do that in the rendering function. Like the character, let's say the character is called bird, okay? Except what we do in our program, sorry about that, in our program all we call it is mesh. It's always got the word mesh because we only have one character that can move like that. So we call it mesh. And its position dot X would be equal to this thing right here, new X. So it would calculate the new X position, and then it would calculate the new Y position right above it, right inside the function here. All this stuff here would be inside the function. And what that would do is, that would move the bird to the proper position. Now, if you ran the program like that, if you just ran it like that, what would happen is, the bird would definitely be in the proper position. The question is, which way would the bird be looking? Okay, well, it would always be looking the way it was looking originally. It would keep looking this way, so it would be flying like this, flying like that, it would be flying backwards and frontwards, and everything like that. So the question is, you got to get the bird to actually face in the direction he's moving in. Okay, well, the way to do that, it turns out, it's kind of easy way to do it. You simply say, well, okay, I know the angle. I know this angle right here with nose. I know the angle off from zero that the bird is flying. Okay, if you simply say whatever that angle is, make the bird fly 90 degrees to that angle. So you basically rotate the bird so it's pointing in the right direction. In this case, we go this way, sorry, go that way. And whatever this angle is, it'll always add 90 degrees, so it'll always be over there. It'll always be pointing in the right direction no matter what. So basically what you do is, if you say the angle of the bird, like right here, you say mesh dot position, not position, sorry, angle, rotation, around, in this case it's around the y-axis, is equal to the angle. If it was just equal to the angle, which is, I write that down right here. If it was just equal to the angle, he would be flying, always facing the same direction as he was originally. So what you do is you say, he's